Okay, class. Doesn't look like everybody's going to show up for today, which I understand considering I hadn't been in a couple meetings lately. But I'm going to go ahead and do a lecture for you. And in particular, today, I am going to lecture on network monitoring, some of the network items, network management. So I'm gonna lecture a little bit on module 10. So let's talk a little bit about what we're going to look at in this particular module. In this module, we're going to talk about a layer 2 protocol that is proprietary to Cisco called CDP. It's a pretty handy little protocol that you can use when mapping networks and also when just trying to troubleshoot, especially if you can't get access to a remote device. We're going to start up Packet Tracer so I can kind of get you and give you some examples of that. Then we're going to look at an open standard that does the exact same thing called LLDP, or Link Layer Diagram Protocol. And then we'll look at NTP, SNMP, a little bit of syslog stuff, and then some router management for files and iOS. So to begin with, let's talk about CDP. Now, CDP is a layer 2 protocol. So I'm going to pull up, put a couple routers and devices out here and just kind of show you how this particular protocol works. And so we'll do gigabit to gigabit. Now, what I will have to do is I will have to bring the interfaces up on the routers. Otherwise, obviously, this entire setup won't come up. So let's wait till the router boots. And then I'll go into gig 001 and do a no shut so it will come up and run. But as a layer 2 protocol, this particular protocol will work. Let me call this host R2. Int G000, no shut, do right. So we'll see that starting to come up. We'll go over here. We'll do enable config T host R1 int gig int G000, no shut, and then do right, which is short for do right config. All right, so we've got a Cisco switch 2960 in the middle, and we got two Cisco routers sitting here. Now, there are no IP addresses on the router. So if I go into the router here and do show IP int brief, all right, you'll see there's no IP addresses assigned. The interface is up. Would have to be up in order for the layer 2 protocol to work at all. Same thing over here. If I do show IP int brief, you'll see on R1 there are no IP addresses. Okay. But if I run do show CDP neighbors, you will see that this R1 is directly connected to a device with the name switch. Now, if I go over and change the switch's name, so let's go to the command line here and actually change it to config T host S1. All right, and to do right. You don't have to write config, but I just did it for fun and giggles. If I run the command again, you'll see that it actually pulls the host name off the switch. It also tells me what port I am connecting to that switch out of on my device. And even better, this is where it's really helpful, what port I am connected to on that device. Now, this is super helpful if you're in a situation where I teach a lot of guys in the Navy and ladies in the Navy, and one of the things they do is they may have a switch on another part of the ship, but they're at a device and need to know what port they are connected to. Well, they can do a show CDP neighbor and see the port of the actual device they're connected to. It even tells you what the device is. You can go further. You can do show CDP neighbor details or detailed, and it will go as far as to show you the name of the device. Okay. It'll tell you if it did have an IP address, it would give it to you. It'll tell you what this is. In this instance, it's a 2960 switch. It'll tell you the iOS image running on that device. And obviously any other little items here that's available. Now, still showing this other switch because it hasn't timed out yet. It still thinks there's a neighbor called switch, even though that neighbor is not really there. It should time out in a little bit. And so it's got a hold down of 40. So here in just a little bit, it's going to go away in 35 seconds. But you'll notice when I do a show CDP neighbors from router 1, it does not show router 2 because CDP will only show directly connected neighbors. Let's see if this is not gone yet. In 19 seconds, that's the top switch entry will leave. because it will be timed out. It's no longer there. All right. Now, if I go to the switch and I do a do show CDP neighbors, notice I've got two devices, R1, R2, obviously, because it is connected to two Cisco devices. Now, this will only show Cisco devices with CDP neighbors. It's not going to show any other device, or it could show devices running CDP. Many hackers actually load CDP as a protocol on their hacking tools because this is an excellent tool to give you information. You know, if I did a, I'm going to drop that here and just do it so you're not show CDP neighbors detail, and you'll see here it's telling me that R2 is a 4300 series router. I am connected to it via my, on this case, on switch 1's gig 02 is connected to R1's gig 000. This tells you that it is a Cisco iOS Everest running 16.6.4. And likewise, it shows me all the information about R1. So switch 0 being connected to two Cisco devices gives me information about 2. Switch 2 being connected to, or excuse me, router 2 being connected to just 1 will show us that it is only connected to S1. Now, if we go back over here now, we should see that the switch is gone because the hold timer for that initial entry when it was named switch has gone away. So it's no longer seeing that quote second switch, which is really not a second switch. So this is a neat protocol that you can use for troubleshooting. You can use it for your network management. It is a Cisco proprietary protocol, but it is very handy. You can use it. One of our packet tracers will have you try to map a network using it. One time at Cisco Live, there was a hacking challenge, and one of the easiest and quickest ways to map the network and find the IP addresses would show CDP neighbors detail. This is a protocol that many security experts would tell you to turn off, but I'll warn you, this is a protocol that in most cases, if you're running Cisco IP phones and voice over IP systems, you're required to have CDP on. So be careful just blanket turning CDP off in all instances, because you may not, you may break something, may break stuff. All right. Now you can turn it off if you want to by doing no CDP enable, and that will, you can actually do it in like a global config command. So I'm going here and go to config T and do no CDP and run or enable. Either one should work. Nope, it's got to be no CDP run in this particular iOS version. All right. So I do no CDP run and then do a do show CDP neighbors. You'll see CDP is not enabled. So that turns it off. Now, if you want to turn it back on, you just do CDP enable. CDP enable. Actually, you know what? You got to do enable CDP. Nope. CDP enable. CDP run. All right. Should have worked before. I don't know why it didn't work. Oh, I tried enable instead of run. Okay. CDP run. Sorry. And then now if I do a show CDP neighbors again, you'll see that it's trying to find the CDP neighbors. It will eventually do it. Takes a little bit to get up and going, especially inside a packet tracer. Okay. Now, since this is a proprietary protocol, IEEE developed what's called Link Layer Discovery Protocol, LLDP, Link Layer Discovery Protocol. I think I called it datagram earlier, but it's LLDP, Link Layer Discovery. It works exactly like CDP, except it is an open protocol. You can turn it on by doing LLDP run. So if I wanted to convert this network to using LLDP, I could go into a global config and do CDP run or LLDP run. Okay. And then I have to go to every single device, LLDP run, and turn on LLDP if I want LLDP to work across my network. And then you can just use the commands show LLDP, and then it's got the same thing as neighbors. So there we're seeing the LLDP gets much of the same information. It's a little more capable. You'll see it has a DOCSIS or a cable modem capability. Can look for wireless access point, repeaters, and let's see if it's got the detail. Yep. So there's CDP neighbor detail. It tells you on this the chassis ID of what you're connected to, which is the MAC address, the name, what it is, iOS version, and all of those things, and media capabilities. So it gives you a little bit more information than CDP shows in its base configuration. Let's go up to switch 1, drop out of here and do a show LLDP neighbors detail. You can see here that here's what it tells you about a router. It tells you what port you're connected to on that router, what port on your device is connected to that other device, the name of the opposite device, iOS information, and its media connection capabilities. Okay, so pretty neat little protocol. It's again simple, easy to use, and designed to be set up between devices that are not Cisco devices. Okay, so typically you're only going to run one or the other, but there may be some instances where maybe part of your network is Cisco and part of your network is not, where you may run CDP between your Cisco devices and LLDP between devices that are not Cisco. But just like CDP, LLDP will only show you your directly connected neighbors. So again, if I look right here on R1 and do show LLDP neighbors, it's not going to show me R1. Excuse me, R2. But now if I connect R1 to R2 and bring those interfaces up, now that's a key thing. You got to bring the interface up. Otherwise, those layer 2 protocols aren't running. Gig 0, 0, 0, 1, no shut. And then I'll have to go over to R2 and bring up its gig 001. G 001, no shut. And once the interface gets up and fully running, I'll be able to go back over here and do a do show CDP neighbors. And you'll see now we've got both S1 and R2 as a neighbor. Be aware, none of these interfaces have layer 3 information on them. So there's no IP addresses on any of these interfaces. So this is a completely layer 2 protocol working at data link layer, both CDP, which is Cisco proprietary, and LLDP, which is an open standard. Kind of a neat little protocol there. All right. Now, another very common thing we find on our internet, on our networks today, is a time service. It's very important, especially if you're going to prosecute people that break in your network, that your time and date is correct on your networking devices. Otherwise, you go into a court of law, you try to prosecute someone for breaking into your network, and you bring in your network logs, and they say that the person broke in, for instance, let's look right here, let's do show clock. And you can see this is 1993. So if I don't change the time and date on this router, and then I had logs from it, it would show that the perpetrator broke in sometime in 1993. Now, if I'm a decent lawyer, I'm just going to look at the judge and jury and say, well, folks, in 1993, my client wasn't even born. So how could they have done this? You're going to look like an idiot. The case is going to be thrown out, etc. So it's extremely important that you do set correct dates and times within your network. Now, you can manually go to every single device and set the date and time, but that is very difficult. It's better if you can run network time protocol, or NTP, and you'll see that there are different levels. Stratum 0 is the top. That's basically the atomic clock, pretty much. Stratum 1 is the top layer all the way down. So Stratum 0 gets it from an authoritative time source. Typically, Stratum 0 are atomic clocks and GPS clocks. So they are the most accurate time sources. Stratum 1 are network devices that connect directly to an authoritative time service. They are the primary time standard, and then it can go on down from there. We can set a Stratum 1 level on our network as a top layer master, and then have everyone else go to that NTP server. And that's probably typically what we're going to do. is set up an NTP server that is going to be our master server for our network that pulls something directly off a Stratum 0 clock. And then that Stratum 0 clock will feed it, and then it will feed inside. In this case, you'll see that we've got our router that is sitting in our network going out to a server 209.165.200.225. Let me see if I can find NTP Stratum 0 sources. This will be a world source. Let's see. I don't know if there's any IP addresses. There's a couple internet time servers that are out there. Now you do want to be careful because one of the things that could happen is someone could actually break into one of these time servers and try to change the time or mess with the time. But you could use one of these as your as a time source, and then you could have that then feed down into your network as part of your NTP configuration. So NTP server would then pull your information off of that, and you would hopefully get the right date. Obviously, this is wrong, but this is when this particular section of information was pulled and placed into the curriculum way back in 2019. So your devices inside your network could then set the other authoritative or stratum to the ones you set internally. So here we've set up basically our R1 as a stratum 1 server, and then our S1 is pulling information off of that, which is actually sent as a stratum 2. But what you definitely want to do is make sure all of your devices, including your servers in your network, all have the same time. This is also important when you get into synchronizing the Windows database and the Windows catalog servers and those types of things. You've got to have an accurate time. Otherwise, you can get into a lot of trouble. Likewise, you can get into trouble with certificates if your time is off or your date is wildly off. Okay. So NTP, set it. You want to have it on. Simple Network Management Protocol is an interesting thing because in its pre-SNMP3, SNMP v3 versions, it had some pretty bad security issues. But it's basically a management software that has an SNMP manager, and then on all your devices, you load an agent. And those agents then, depending on what the device is, has a database of items that can be queried and or set from each one of those devices. So for instance, on an SNMP agent on a router, you may have the ability to do a show interface gig 000 or gig 001. You may have the ability to actually put an IP address into an interface using SNMP. So the agents are purpose-built for each device they're loaded onto. And then you can have things called traps. And by the way, the database is a MIB, Management Information Base, and that's what the objects are in terms of that. And it actually talks about that a little bit down here in the curriculum, or a little bit later in the curriculum. It looks at version 10.4.7. Well, we'll show it to you in a second. But it shows you a MIB database. But here it is, basically information. You can set it to where the manager can send get to get information off of a particular device. It can send set to set information on a device, or you can set what are called traps. And that is basically when a particular item in the MIB database reaches a level or hits a trigger point, it will then send a trap or a informational message to the SNMP manager. And then, of course, all kinds of things can happen. The SNMP manager can send you an email. It can automatically shut an interface down. There's all kinds of things you can do with it to make it useful. But again, get request gets a specific variable. It asks for a variable out of that MIB database. Get next will look at the next item in the MIB database and give it to you. Bulk requests are for large bulk information requests in the MIB. Get response is a reply to a get request. All right. And then set request puts a specific value into that MIB entry. So you can either get a MIB variable or set a MIB variable. This can be a very dangerous protocol, especially in version 2, because you set things called communities, and those communities by default were called public and private. And as long as you knew the community name, you could set anything in the private MIB. And many people didn't do the right thing and didn't change those. And so there were a lot of tools out there that would let you with SNMP version 2 just jump in, pull information using the MIB database, and then even set things that could cause major issues with your network. So SNMP 3 was designed to change that. Now it looks like here there's something wrong with the curriculum. That's hilarious. So the curriculum broke right here for some reason. I don't know necessarily why, but it is broken. But from a real world standpoint, don't use anything but SNMP v3. Otherwise, you're asking for your network to be broken into. Here's your community strings. Again, the read-only string used to be called public. The read-write string was called private. You definitely want to change those from the default, but that was a major issue in the very beginning. Okay, and then here's what a MIB is. It's just a hierarchical database. So they would have like ISO, org, DoD, internet, all the way down and local variables. And it really just came down to a way to put in place items that were specific to the devices that were being managed by SNMP. So for instance, a router may have show IP routes, whereas obviously a wireless access point may not. So you can actually go all the way down and have specific items in the MIB that are related to the device that's being managed. Now here's an example of a good example of how SNMP can be used. You could set up a trap that would keep an eye on the CPU usage, and if it ever exceeded a certain value for a certain amount of time, that would force the router or device to send you a trap and say, hey, CPU usage is high. And it would be sent to the network management station, and then the network management station again could do multiple different things. So here's an example of SNMP get. This is actually a request from the command line from a network management station, but basically saying get from the community this IP address. This is the MIB number, which ends up being the MIB for CPU value, and this would report what the current CPU is set at, or what current CPU usage is at. You can actually look on Cisco's website at the MIB Navigator tool or SNMP Object Navigator tool and find the names for or the actual OIDs for objects in the MIBs that relate to Cisco devices. Okay, a little bit beyond the scope of the CCNA, but it's just kind of neat to have if you know it. Okay. Then we also have what's called syslog, and syslog is a small it's literally a logging software. It's been around forever and a day. And what it can do is you can take your system logs and you can send them to a syslog server. You can also send just your informational and warning messages off of your devices. So you can log everything to a syslog server. Be aware that syslog does use UDP and port 514. So if anything is already using port 514, you could be in trouble. Nothing uses it, but but syslog 99.9% of the time. So it's been around forever and a day. You can actually do all your logging to a syslog server. You need to be careful that you don't log too much, because you can log so much that you don't really even go look at it because there's just overwhelming knowledge. You'll notice that there are multiple syslog levels, and this is something you kind of need to at least commit somewhat to memory, and that is the lower they get, the more urgent they are. Okay, so a level 7 message is just a debugging message, which is basically you're running a debug program, so it's going to tell you what's going on during that. A level 6 is informational, so again, not anything majorly big. You've seen those before, especially on the console when you do something like this. Well, right there was one. Look at this. Link 5 changed, state up. So if you look here, a level 5 is a normal notification, or it's a notification. Level 5 significant, that's a normal but significant condition. So in this case, we had a log to the local console that said that the interface changed up. Now, if I go in here and do a config T and then just put a banner, MOTD pound test banner. Okay, space, pound, enter. If I type exit, watch what happens. Okay, here's another normal notification. Configured from console by console. If I turn on debugging, debug CDP, let's see if I can do that. Let's do, now never, ever do this in the real world. Okay, do not run this command in the real world. I'm gonna put in debug all, because I just want to see if I can get it to actually give me some debug, but don't ever put this command into a real, they don't have it here, debug IP. This, since it's a, since this is packet tracer, we don't have debug all and undebug all. So I can't really do anything here. But I was trying to show you debugging. If I had debugging on, it would give us level 7. On down now, when you get to level 4, that's a warning. So there's a warning condition, something's happened. Level 3 is an error. Level 2 is critical. Level 1 is alert. And in level 0, the system's basically unusable. It should crash at that point. Here's an example of a level 6 informational, except in the EULA. Okay. You can syslog items into the syslog server, and when you do that, the messages going into syslog tell you what was the actual creator of the syslog message or the informational logging message, and then it tells you information about it. So here we see here, if says it was generated by a interface, IP, it was generated by IP, OSPF. Those are some commons. This is a link, so this tells you it's was generated by the link facility. That's a severity level of 3. The mnemonic is up down, so it tells you what it's relating to, and then here's your actual informational message changed to up. Now it's important that when you do set up syslog, you do set a timestamp. So you want to have set NTP already, and then you can do service timestamps log date time. And then that will let the date and time be added to your syslogs. Otherwise, you don't get the date and time, you just get the message. So this is something we want to do in 99.9% of all of our network devices. Let's set it up so it can log it. Okay. So syslog is neat to have. Again, the biggest problem with syslog is if you're not careful, you can get so much information into the syslogs that they're overwhelming. You really almost need the ability to take your syslog server and dump that information into another management software, and then have that management software only pull out the items that are, say, level 3 or 4 and lower, so that you're not constantly messing with items that while are important, aren't really that important for you to know about. Okay. Now, on a router, routers and switches do have file systems, just like a regular computer. They have file systems. If you do a DIR here, you'll see what looks like a file system that is fairly similar to what you would see inside of a Linux box. All right. Now, this is packet tracer, so you're not seeing some of the things that you would see on a real a real device or real router. I tried to do show file systems. I don't even know if this will work in packet tracer. Packet tracer. Nope. So it doesn't. Let's see, file system. File. Yep, there it is. Shows you a little bit, but you'll see there's very little there. You got flash and NVRAM. Whereas on a real router, you'll have a whole lot of different things here. One of the things we use often is the USB, especially if we're trying to move iOS images. It's much easier to use in USB to copy iOS images back and forth onto a device and into flash than otherwise. You also see on some of our newer devices, especially 4200 series, 4300 series, and above, it's not just flash anymore, although you can use just flash as a keyword. Boot flash is actually what the directories are called. They're using an alias here so that boot flash and flash are seen as the same thing by the device. Here we have a directory inside of boot flash. So we did dir of the boot flash itself, and it shows you everything in the boot flash, including the iOS images that are there. And then the NVRAM, CD to NVRAM, and you can do PWD and do a directory of NVRAM. Let's see if it'll let us do that inside of Cisco CD NVRAM colon. Nope, it won't let you go there. So since this is a simulation, it will not let you go in the NVRAM CD flash colon. Nope, it just won't let you because it's not simulating that part of the file system. But on a real router, real switch, if it's got NVRAM, you can actually go in the NVRAM. You can see what is inside of there. All right. Here's switch file system, very similar. You'll notice this particular switch, since it's probably a 2960, does not have a USB port on it. Now, how can we back up text configurations? This is one way they talk about doing it with a log. Folks, that's not how I'm going to do it. If I've got a config here, I'm going to do a show run. I'm going to run it down till I got the whole config. Now I'm going to go up here and grab it just like this, copy, and I'm going to dump it in the notepad. Okay. And then I'm going to clean it up, because really all I need for this particular thing is, getting the host name, all this stuff. Other than LLDP, I know this stuff right here is on by default, so I just get rid of all that. And let's see, spanning tree, PBST. I'd take that out too, because that's the default. That needs to stay. That stays. You could get rid of that if you wanted to, but you can also leave it. And then if I had any other configs, I would do that and you get rid of the end. That's how I save my configs. That's just a whole lot easier than trying to do this log, name it, do a show run, and then that's just too much work. Okay. Now, if you want to restore a file, it's really simple. I just go in here and do a config T, and I paste. Now I go in here and find my notepad. I closed notepad, didn't I, like a doofus? I did. Okay. Well, if I had it in notepad, I would have just taken it and I would have pasted it and let it drop all the way in. And you'll see here, boom, it would have dropped it in. Okay. So that's how I do it. It's the simplest way. You can also back up your configs by just copying them to a TFTP server. So you can copy your running config to a TFTP, put in the IP address. The most common problem I find with TFTP is that people forget, if you can't ping it, or you can't read, most times you can't ping it, you're not going to be able to TFTP to it. Sometimes you could, because it could be an ACL blocking pings, but allowing other things. But be aware, make sure you have connectivity to your TFTP server if your TFTP is failing. But otherwise, it's pretty simple. You just put in the IP address of the remote host, the name you want it to be, and then you copy it up, and the exclamation point or bang says that those are successfully copied packets. Okay. Here's the USB port on the back of a Cisco router. So it can put in USB flash drives so that you can actually back up and restore configurations to the USB drive by doing things like copy, run, and config USB flash 0. And they get that by just looking in here at the USB and seeing that it's a USB on here, flash 0. Well, they're not showing USB here, but it's there. Oh, there it is. Yep, last one, USB flash 0. So you can copy there. You could even copy the flash there if you wanted to. So the iOS, you copy the iOS there if it had a USB drive. So that's a good way to back up your iOS images, is doing a, if I had a flash drive on here, I would do copy flash colon, or a USB flash colon image name. Now that's obviously not an image name, to USB flash 0 colon. All right. And then you'd hit enter and it would copy over if I had a USB in this R1 and if I had put an actual image name. Now, how do you get the image name? Well, most times hit directory and it will tell you the image name. So if I was copying this to a USB flash drive, I would do copy flash colon or boot flash. Sometimes, depending on the iOS version, I put in boot flash. ISR 4300 universal K9.16.06.04.SPA. And remember, it is case sensitive. USB flash 0 colon. Hit enter, and that would actually copy the iOS image from the local flash to the USB. And then you could carry it and store it somewhere else. Or if you needed to get all your routers on the same iOS image, you could copy this and then copy them into the flash using the reverse of this. So you could do copy USB flash name, flash colon, and then whatever name you want to copy it into, which would be the same name of the image. Okay. Now, how do we do password recovery on a Cisco router? Well, first thing is you got to do is you got to send or get into RMON mode. And typically to do that, when the router is booting in the first 15 seconds, you have to hear send a control break. Or if you're in a program like PuTTY, there's a way to send a break by clicking on the program itself and saying send break. And if you do that, it's going to drop you into ROMMON mode. Now, once in ROMMON, you're going to change the config register from the default. So typically, the default config register is 2102, which says boot from flash, or boot from NVRAM, the startup config. We're going to change it to 2142, which says ignore the image, the startup image in NVRAM. You then, once you reboot it, okay, now notice you reboot, change it, then you reset. It's going to boot up and look like it's a blank router, but it's not really blank. Your config's still there, all right? It's just, it bypassed it. And you'll notice at this point, even though you've forgotten your enable secret password, you're able to get into global, privileged exec mode. You'll then copy that old startup config file to the running config, change the password that you messed up. Please don't change it to Cisco. All right. Save the config, change the register back to 2102, and reload the device. Make sure you remember to change it back. Otherwise, it could be 6 months, 2 years, 3 years later, the router reboots, and you forgot to change it back to 2102, and it bypasses your startup config, and you got a router that looks like it has no configuration on it. All right. So make sure as part of the password recovery procedure, you always change it back to 2102. Now, this is on a Cisco router. On a switch, it's a little different. On a Cisco switch, you have to hold down the RMON or the mode button in the front, take the power off, put the power back on, wait till it blinks amber, let go. It's going to drop into RMON. Then you've got to do load helper and the flash command, boot flash, and then you go in and you can change the startup config. You can actually rename the config.txt to config.old, and it will bypass it, and then you can reboot it. That's not really in this particular section on this lab, but it does have you go look that up. So be aware of that. It's good to know that. Now, some of the things about iOS images, big thing is back them up either to a TFTP server or to a USB drive. I would probably do it to a USB drive because it's easier. and then store them somewhere on your network. The other thing is make sure you're able to go and get the newest images, or try to stay up to date with your images, because that is very important. If you don't have the latest image, then you may be susceptible to who knows what kind of security issues. So here is one of the issues we do find sometimes, is that there's not enough room in Flash to store the new image and the old image. But in an ideal world, if you can store both the new image and the old image, you keep both images in Flash, and then you use the boot system command to set the router or switch to boot with the new iOS. Run it for a couple weeks, everything works fine, then you delete the old image. Heaven forbid you boot it up and it's not working right with the new image. If you've got both images in Flash, you just tell it boot system Flash, point it to the old image, roll back, delete that new image until things stabilize, or whatever the problem is fixed. So there are ways of doing that. It's uncommon that lower level devices have enough RAM or enough Flash to hold multiple images. But on high-end routers and switches, they usually have enough Flash that you can store multiple images. And then when you want to upgrade, you just tell it, you load both of them into Flash and say boot system Flash : or boot Flash : give it the name of the new image, exit, copy, run, start, reload, and it will boot with that new image. And again, let it run a couple weeks. If everything's fine, then delete the old image. But if you reboot it and there's all kind of errors and problems and there's issues in your network, then just change the boot system Flash command to point it back to the old image that you've left in Flash, and then you can delete that image you put in there and roll back. So the boot system command is neat to allow you to boot between different iOS images that are in your Flash, and it's extremely helpful when upgrading a device to a new image, especially in the real world. Okay. Well, everyone, that is the lecture for today. Again, sorry it was just me talking to myself, but I did want to give you a lecture that you would have so that you could look at it. We will continue lecturing next week. I'll have another lecture for you. And we are in the last month of class. You have a month to finish this CCNA 3 class. If you have any questions, please send them to me. My email address, send them to me, and I'll try to answer them as quickly as I can. So thank you very much, and have a great week.